Welcome everybody. I've been told that we are live. We are going to be doing something kind of cool today. This is the second one of these videos in a series where we have an instructor come in and take a live section from one of the official practice exams in front of an audience. And we have no idea how it's going to go. It could go very well. It could go not very well. We will find out shortly. But a couple weeks ago, one of my colleagues came in, Ryan Starr, and he took the data insights section from official practice exam number 2 for the GMAT Focus official practice exam suite. Remember, you can access those in your official starter kit at mba.com. It's one of the 2 free exams. So he took the data insights section from practice exam number 2, and I will be doing the same thing today. We're also taking the data insights section from official practice exam number 2. And as I'm going, I am going to be, I don't know, stream of conscious describing what I'm seeing, hopefully, describing my thought process here and there, and selecting answers in real time. And I invite you to follow along with me. So if you have not taken official practice exam 2, just a heads up, there might be some spoilers ahead here. You may see some of these questions when you eventually take your second practice exam. But yeah, I invite you, if you're following live, to try to participate with me. And if you're watching this on YouTube on a recording afterwards, yeah, follow along, try to attempt these problems. If I move too quickly through a problem, feel free to pause it and give yourself a little bit more time. But do keep in mind that we do have 45 minutes to get through this data insights section. And then I believe in a few more weeks, we'll have a third Manhattan Prep instructor come on and maybe do a quant or verbal section in the same way here. In an attempt to have you better follow my work, I have like an online whiteboard I may make use of. I don't know, the tech might be a little clunky. We'll figure it out. But yeah, I'm looking forward to this adventure. And yeah, we will see how things go. All right, let's get started. Let's present. I'm going to present my entire monitor over here. Yeah, let's do this entire screen. And you can see what I've done already here. Oh, it's going to pull up in a second. But what I have done is I have just randomly clicked through the quant and verbal sections of practice exam 2. Be interesting actually to go back and look at those later and see what problems they're giving me at the ends of each section, in the middle of each section. If I've missed a bunch of them, that could be a cool experiment. But we are at the break between the verbal section and the data insight section. So here we are. I'll hide this. And yeah, I do have this this whiteboard I might kind of pop up every now and then in case I want to do some work. Shall we begin? Let's give it a shot and see what happens. All right, we're going to continue exam. You got the data insights instruction, right? It kind of tells you the 5 problem types we're going to see. We're going to see a multi-source reasoning prompt, hopefully only one. I don't want to have to deal with 2 of them, but we'll see what the GMAT gods have in store for me. I'm going to do some table problems, some graphs, some 2-part analysis, and then the data sufficiency, which has been kind of reduced in importance, so to speak here. I put it in the data insights section, and there are now fewer data sufficiency problems than there used to be. All right, go ahead and click next. Oh, and here we go. We're off and running. Got 45 minutes for 20 questions, and we're going to start with this DS problem. Let's take a look. Of the people who donated money to a certain local theater last year, a quarter donated a little bit. 2/3 donated more than 200, more than 20, but less than 1,000. All right, so already here, what I want to do is I want to make like a little inference, because they've told me about 2 pieces of the whole, right? A quarter of the people and 2/3 of the people. And what I'd like to do then is just kind of draw this little inference over here and say, well, a quarter plus 2/3, well, 2/3 is really 8/12, and a quarter is really 3/12. So far I've got information on 11/12 of the people. So I still am missing information about that last 12th. Where is that last 12th? If the average amount donated by the people who donated more than 20 but less than 1,000 was 180, what was the average amount donated by people who donated more than 1,000? So these extra 1/12 of the people. All right, what was the average amount donated by the people who donated $1,000 or more? The average amount donated by the people who donated less than $1,000 is 132. So what I could do is I could create a weighted average system here and say like, well, there's 8 to 3 in terms of like how many people donated in this middle range versus this lower range. I know that this greater amount is at 180. This lesser amount gets me for them to like that 11/12 to be 132. Okay, so that kind of tells me, that would tell me the average amount donated by this quarter. Okay, but does that tell me the average amount donated by the people who donated more than $1,000? I do not know still how much the high rollers donated. So I would knock off answers A and D. I don't believe statement 1 is sufficient. Get rid of A and D. Goodbye. The average amount donated by the people who donated more than $20. So that is going to be this 2/3, and the missing 1/12, this is already looking sufficient, is 360. So I already know that this is 180, right? The people between 20, the middle people have donated 180. The missing 1/12, then take that two components, the 8/12 and the 1/12, the weighted average is 360. So I should be able to figure out precisely where this average is. So I'm going to say statement 2 is sufficient and move on. I could review that a little bit more later, but I don't have time for that right now. Actually, the stream of conscious stuff is taking kind of a while to do. See if I can be faster. Got a graph problem for each of the several continents. Total precipitation is shown. Very cool. The height of the column represents total precipitation. So what I'm seeing is like Asia gets a lot more precipitation than Australia, right? High bar, low bar. Percentage of precipitation that returns through atmosphere through evaporation and percent that runs off is also shown. So like as an example of this like bar that Africa shows here, right, which is less total precipitation than Asia, but more than Australia and Oceania. 80% of it evaporates, 20% runs off. Cool. The total volume of the annual precipitation that directly returns to the atmosphere is lowest where? All right, so I need to figure out, I need to take the evaporation, right, percentage, and multiply that by the total amount to figure out what's going to be the lowest volume. I'm looking at Australia and Oceania just because it's so tiny. 65% of this tiny number seems like it's still going to be pretty small. I see Europe, 65% of its number. Europe's value is smaller than Australia, so I think 65% of Australia and Oceania's number is going to be the least. I could have looked at my answers. It might be a pro tip here. Look at your answers to see, can you eliminate anything? There's only 3 possibilities. 65% of Europe, 55% of North America. No, 65% of the smallest value is going to be the least. Of the total combined annual precipitation in Europe and Asia together, how much runs off? So what I'm going to have to do is I'm going to take 35% of 8290 plus 35% of 7080. Since the, oh, sorry, no, we're doing Asia, not Australia. 35% of 8290 plus 45% of 32,000. We'll add those up. Maybe we could estimate this. Let's see. Okay, we have to combine this. I think we could try to be tricky and do a weighted average. Say like I'm blending 35% and 45%, and the Asia value is just so much higher that the weighted average is going to gravitate pretty far to it. So the plain average would be 40% here, but because the Asia total value is just so much more important, we're going to gravitate towards that. So I need something that's between 35 and 45, but closer to 45 than 35, and it's got to be 43. I think we could probably check that on the calculator, but I feel pretty good about it. Let's move on. Where are we off to next? Off to a table problem. Cool. Let's take a look at the table. We've got a bunch of employees. Looks like, I don't know, 19, A through S. Okay, a bunch of sales numbers. Cool. So how much they sold maybe the current year versus the previous, the change, percent change. Awesome. Let's double check that we've got this. Each of the 19 people eligible for 3 yearly bonuses for the current year. Cool. The first bonus, 5,000 paid to each member. Sales staff. Okay. The second bonus, 800 paid to each of the 2 people with the greatest increase in total sales, so not necessarily percentage. And then third bonus, 300 with the 2 greatest percent increases. All right, so we have 3 bonus types. 5K just paid to people who make 200,000, right? So for like A is not going to get it, B is not going to get it, C is not going to get it, E is going to get it, right? E gets it. Cool. understand that. Second bonus, 800 paid each of the two salespeople with the two greatest increases. Cool. So would you want to check the increases? Who has the two greatest? They are in line for an $800 bonus. And then 300 paid for the greatest percent increases. Check the percent increases. Who has the greatest two values there? Awesome. Exactly 6 members will receive a bonus totaling exactly $5,000. So are there 6 people that have sold more than $200,000? Essentially, is what that's asking. Let's sort by current year. Boom. How many people make over 200,000? PROQGEL. That's 7 people. So not 6 people. Get out of here. Let's go to option 2. Exactly 1 member will receive a bonus. A bonus is totaling exactly $800. How do you total $800? Well, you just get the second bonus. Okay, so you get the second bonus and you get only the second bonus. So how do you get a second bonus? You have one of the top 2 total differences. Let's sort by total difference. Boom, we've got B and F. They're the ones who would be in line to get it, B and F. But we have to check that they're not going to get another bonus. So they're not going to get the big bonus for reaching 200,000, but are they going to get one of the percent change bonuses? And it looks like they're also going to be the 2 people who get the percent change bonus, right? They're going to be the 2 people who have the greatest change here and the greatest change here. You could just sort by that percent change. They're the same 2, B and F. And so, no, that's not true. No one's going to get an $800 bonus exactly. Take a look. Exactly 2 members will receive a total bonus of $1,100. Yeah, that means you get the $800 and the $300 bonus. Those were people B and F. We just did that one. This is going to be a yes. Got to keep going. Okay, I think I got to hurry up. I'm talking too much. I mailed at least 1 letter each day last week. Was the total number of letters that she mailed greater than 27? All right. Cool. So total greater than 27. Let's go ahead and jot that down. I mentioned I was going to be faster, and here we go. Total more than 27? Question mark. It's a value question. All right. Want to mail fewer than 8 letters on each of the 7 days. Okay. Well, she could mail 1 letter on each of the 7 days, or she could mail 7 letters on each of the 7 days. That's not going to be sufficient. We are eliminating A and D, so I have B, C, E, and left. Let's take a look at statement 2. I want to mail the different number of letters on any 2, different number on any 2 of the 7 days. Well, if we do that, like, what's the fewest number of letters she could send? She could mail 1, 2, 3, 4, 5, 6, 7 letters on each of the weeks, each day of the week. That's already 28 letters. And that is like the minimum possible, right? She has to mail at least 1 letter on each day of the week. So I believe this tells us that this is going to have to be true. Statement 2 tells us, yeah, she has to, the fewest she could mail is 28. So that's greater than 27. We are done. All right. Maybe I saved some time there. Okay, here's our MSR prompt. Let's take a look. It's going to be, let me take a little time to read this. Cities, A, B, C, D, and E. A, B, C, D, and E. Cool. In the diagram, circles represent the 5 cities. Each line is a flight line. Direct flights currently offered between the 2, which is called a terminus. For all flights represented by the line. Okay, flights are offered in both directions. For each flight in the diagram, all the flights offered by SkySoar are represented. Cool. All right, so this is basically like the exhaustive flight path route of all of these cities. Cool. Yeah, the label for each flight shown on the duration is in minutes, and each of the flight connects annual revenue in millions. So it's 101 minutes from A to B, and they make 33.1 million between those 2 cities throughout the year. Direct flight is not available. It may take packages on a sequence of flights. Total flight time, which is the sum here. So if I wanted to go from A to E, I'd have to add 101 plus 78 for 179 minutes. Cool. All right, take a look at the new flight lines. Okay, connected research. Are we going to add a single new flight line? Very good. So take a look. If we're going to add AD, that will connect us right here. Cool. Projected to adding a new line will make another change. Reduce the annual revenue quoted by all flights that share terminus, okay, by 10%. So you take a hit a little bit there, probably because you're missing some connections that you otherwise would have gotten to each of the 5 proposed things. Cool. All right. Let's take a look at the problem. SkySoar would like to add a new flight line. Decreases minimum total flight. Cordell and Duark. All right, right now, Cordell and Duark takes 96 plus 78, that's 174 minutes. So I probably want to write that down. So I'm not going to pull up the whiteboard for this right now. 174 minutes. Implementation budget for the, oh my, hello. That's because my pen's here. The new line has been set at 13 million based on different which of the following lines have minimized the total flight time within the budget constraints. All right, cool. So, would AD do it? If I put AD in, AD, does that shorten the flight time? Decrease the minimum flight time. Right now it's at 174. If I put AD in, AD would take 85 minutes. 85 plus 63, that would shorten it. So like AD, I'm going to keep in the running. All right, AD is still in the running. What about AE? AE takes 90 minutes. AE, then CD, that's not going to take too long. So we're going to get rid of AE. All right, AE is out. BE seems like it's not going to help. BE really seems like it's not going to help. 111 minutes. If I add that, that doesn't help CD be any more efficient. So we're going to knock out BE. Take a look at CD. Well, if I put in line CD, that seems like it's going to take less time. Let's double check. CD takes 141 minutes. That's less than 174. And then DE takes 174 minutes. That's already what CD takes now. So the only options I have here are CD and AD. And now I got to check the budget constraints. We need less than 13 million bucks, less than $13 million. AD is going to cost 11.2. CD is going to cost way too much. So this is the only one that works. AD. Boom. Let's go next. Hope I didn't screw that up. I was going pretty fast. With each of the following proposed new flights, select yes. The implementing line would increase the total amount of revenue generated by more than 10 million. Okay, so let's see. If I put in AD, I gain 20.1. But how much am I going to lose? It says I'm going to lose 10% in the revenue provided by all the flight lines that share a terminus by 10%. So if I add AD, what's happening? I am losing 10% of 33.1. I'm losing 10% of 18.7. And I'm losing 10% of this one, right? Because this one also shares a terminus. That's 3.3, 1.8, 1.8, 1.8, that's 3.6 plus 3.3, that's about 7, but I'm gaining 20 million. This seems like it's going to increase. Yeah, up 20 million, but losing about 7 million. That's a win. All right, line AE. AE, we're going to increase by 17.2. Okay. If I put in AE here, I'm going to lose. This one looks a lot closer. 3.31. I'm going to write this one down. 3.31. I'm going to lose 1.87 because 10% of this. And I'm going to lose 1.76. If I add those up, that still seems like it's going to be less than 7 million. That's still less than 7 million. And the new line brings in 17 plus million. So I'm going to go up by more than 10 as a net. And then line BE, 18.8. Okay, if I put in line BE, I'm going to lose 10% of 33.1. So again, 3.31. I'm going to lose 10% of this, 1.81. And I'm going to lose 10% of this, which is 1.76. Add those up. I think we're at about 6.8, 6.9 million there. And BE generates 18.8. I think we're good. Oof. This one sucks. This problem kind of sucks. All right, next one. Last one. Decided its new flight line should have a projected annual revenue of more than 20 million. Cool. There's only a couple that do that. Implementation of the line should also make it possible to travel between any two currently serviced cities by taking at most 2 flights. So no like 2 layover spots. Will these flights do that? So let's take a look at AD. AD does it. BD definitely doesn't because I know it doesn't get more than 20 million. DE does the first part. All right, if I put in AD, can I get from one city to another with at most 2 flights? Well, which ones can't I get to with 2 flights now? A can get to everywhere. A gets to A, B, C, D, and E. B can get to, I think, everywhere as well within 2 moves. C is symmetric with B, so that works. And then the only place I can't get to in 2 flights is from D to E. So basically what I need to do here is I need to link D to E in some other way. Line AD is not going to do that, right? Line AD does not help me get from D to E faster. Okay, so that's going to be a no. But of course, line D to E does. That closes the whole circuit. And now we're going to be good. Yeah, now we have the entire pentagon filled out. With the entire pentagon filled out, you can get from one corner and then one vertex to another in 2 moves or less. Okay, all right. Whew, let's keep going. Two-parter. Session 280X gives higher priority to bills at the level of each of several factor increase. That's the level of each. Okay. Public interest in the bill, cool. Contentiousness, right? So higher priority potentially. Scale, the uncertainty about it, the ongoing relevant research. All right, so there's a bunch of things that if these factors increase, higher priority. The 3 bills all had the same level of public interest. Bill A had the highest level of contentiousness. All right, Bill B, highest level of uncertainty. Same levels of ongoing research. Bill C had the lowest level of all of this stuff. Okay. Gave A the highest priority. All right, why does A get the highest priority even though it had the same level of scale and ongoing relevant research as B? Well, it has higher contention, but lower level of uncertainty. Okay, so what explains why A is higher than something else? Okay, if they give higher priority to the level of contentiousness than they do to uncertainty, that seems like it makes sense to me, right? Like, why did they value A over B when like they're kind of presented as, I don't know, equals in the sense of this, like A is winning in one area, B is winning in another area, they're tied in the third area, C doesn't seem very important. So why does A prioritize over B? I guess they're looking at contentiousness as more important than uncertainty. So we're going to say they have a higher priority to level of contentiousness than uncertainty. I feel good about that one. Irrational confidence. Let's go. All right, got a graph here. Got number of meetings, total costs. All right, so cost of virtual meetings seems to stay the same. There's a linear relationship with number of face-to-face meetings as there with cost there. Okay, that makes sense to me. Replacing its periodic offsite face-to-face ones. Cost. Good, good, good. This is KPI incurs negligible additional costs. Cool. Negligible additional costs for the meetings. All right. Graphic shows one-time cost. Virtual meeting. And let's just make sure we check this. 5 face-to-face is about 20K. Cool. Good. All right. Holding face-to-face meetings, that's the black line, cost the company less. Less than the virtual ones until the total number of meetings held reached approximately, I don't know, 14, 13, something in there, when the total cost of face-to-face meetings would meet or exceed the approximately blank expenses needed to set up the virtual meeting. All right, let me make sure I get this part. Total cost of face-to-face meetings would meet or exceed the approximately blank of expenses needed to set up the virtual meeting capabilities. All right, to set up, so this bar represents kind of like essentially the initial cost to set up virtual, right? Which looks about 56,000. And then it says once those capabilities are established, right? Cost necessary here. Once those capabilities are established, the company incurs negligible. So that just stays the same. So it costs 55K to set up these initially, and then it stays flat. Feeling good. Explanations here probably leave a little bit to be desired. We'll get back to it in the review. Each dinner at this restaurant, pair of side dishes. Haven't eaten yet today. Making me hungry. Customer chooses by selecting one side dish from list A, one from B. There's 18 possible pairs of 18 possible pairs of side dishes. So it could be like there's 9 over here and 2 over here. It could be there's 18 over here and just 1 over here. It could be 3 and 6, something like that. No sides appear on both. If there are fewer dishes on A than B, how many are on B? Okay, so let's kind of just show that. To get 18 combinations, basically, I need 2 factors of 18, right? And what it says is like list A versus list B. There are fewer over here, so I need this factor to pair with this one. The alignment here is all off. It's like my car. 9 and 18, or whoops, 3 and 6. Yeah, cool. So these are my options. 1 and 18, 2 and 9, 3 and 6. How many are on B? Is it 18, 9, or 6? There are a total of 9 side dishes on the 2 lists. That points me to this one here. Statement 1 is going to be sufficient. So we'll say A or D are the only ones left in the running. There are a total of 3 side dishes on list A. That tells me it's this bottom one as well. So both of them point me to this bottom option, which means there are definitely 6 in list B. We're going to pick answer D here and move on. On to the next. All right, 4 years. Oh, classic age problem. Let's pull up the whiteboard for these ones. In 4 years, Ramona's age will be twice Charlie's age in years. Okay, cool. Select values that could be their present ages. Well, um, if in 4 years Ramona is twice as old as Charlie, then like Ramona's older than Charlie, so I know like Ramona can't be two, right? If Ramona is two now, then she would be six in 4 years, which means Charlie would be three in 4 years, which means now he's -1, doesn't exist. So it can't be that. Charlie's got to be less than Ramona. So we could just like try these out, right? If Ramona's 12, then in 4 years she'd be 16. That would be double 8, which means Charlie is now 4. That's not an option, so we keep going. If it's 14, right, then in a few years, in 4 years, she'll be 18. That's double 9. And then Charlie would be 5 now. That's impossible. So let's try this. In 20, if she's 20, add 4 to 24. Cut that in half. We get 12. But then Charlie today would be 8, so that doesn't work. What about 24? If I try 24, 24 plus 4 is 28. 28 divided by 2 would be 14. That would be Charlie's future age, which means he's 10 now, so it can't be that. Ramona's got to be 28. If I add 4 to that, she'd be 32, at which point Charlie would be 16, which means he is 4 less than that, 12 now. Got to be this one. Could you do algebra there? Yes. Do you need to? No. Your choice. Maybe the algebra is like faster. I don't know, but I wanted to walk through that by just showing, hey, we can use these problem-solving techniques of working backwards, plugging things in, and seeing that like we can still get to the right answer even in the data insights section. The flowchart shows the procedure for preparing 4 traditional Nigerian foods. All right, akara, iwa, there's akara, cool. And here are the other ones from cowpea seeds. All right, so there's like a process here. Select the options from the draft menus that create the statement that is most strongly supported by the information. All right, so one of these foods, preparing each of these foods except involves what? So one of these foods, or 3 of these foods contain one of these elements, and then one of them doesn't. Let's take a look at adding condiments and oil. This is the first on the list. We're going to take a look. I don't know how to pronounce this. Gibigiri uses condiments and oil. Moin uses condiments and oil. Akara uses condiments and oil. Prepare it does Iwa. Iwa does not. Preparing each of the foods except for Iwa involves adding condiments. Is it that easy? It could be. Let's just double check. Boiling seeds whole. Where's boiling seeds whole? Right here. Actually, only one of them uses that. Right, so it's like another inverse. Cleaning and rinsing. You clean and rinse everything. Right, clean and rinse is like the first thing you do with the ingredient used for all of them. And then dehulling. Where's dehulling? That only leads to moin and akara. It doesn't lead to iwa. It doesn't lead to kubigiri. I feel good about this one. Yeah, kubigiri, moin, akara. Boom, boom, boom. Only iwa doesn't use condiments. On to the next. Moving along. All right, another DS problem. Very wordy. Very wordy. Let's take a look. Internet only, TV only, internet TV combination. I am internet only. I made the switch at the beginning of the pandemic. I said goodbye TV. Maybe that was the time to keep TV. I don't know. The monthly charge for the internet TV combination, 25% less than the sum. So you get a bulk discount essentially. I like to think about real world considerations when I'm reading these problems. I want to stay like engaged with the problem, right? So yeah, it makes sense to get a discount when you combine the two, right? Bundle up and save. Only 60% of the customers purchased internet only, and the remaining were divided equally between the other two. Which one would generate the greatest monthly revenue? Okay, so there's another inference in here. Let's just go ahead and jot this down. So we got internet only, and what we know is that's 60%. The internet, the other two are divided equally. So right, TV only, and then the combo, those have to be, they have to split the remaining 40%, so they would each get 20. So the combo, 20%. Okay, which of the services would generate the greatest monthly revenue for the company? Monthly charge for internet is only $25 per customer. I don't know how much TV costs. Like maybe internet is $25, per customer here, and TV is $1, right? And then the combo is like 25 plus one, and then you subtract 25%, right? Because there's a discount. Internet wins. But if like internet is $25 a month and TV is like $1 billion a month, then we're spending a lot of money here. So internet would not win. I'm gonna get rid of A and D. A and D are out of here. A and D, boo. We've got B, C, and E left. Monthly charge for TV only is 20% greater than the charge for monthly only. Okay, this one is interesting. All right. So what's interesting here about statement 2 is it gives me like a direct percent relationship between two unknowns, right? And it might be tempting to say like, well, you only know this relationship. What about the combo? Remember, they tell you the combo is 25% less than the sum of other stuff. Okay. So what we could do here is we could like smart number this, but I'm going to say statement 2 is sufficient on its own here. Do I have time? I got some time to get into this. Okay, let's say there's like 60 people here. Okay, let's say there's 60 people here. Let's say there's 20 people here, 20 people, and 20 people here. And let's kind of like assign some values. Let's say this package is like $100. According to statement 2, this would be 20% more, so 120. And then this one here would be 220 the sum, but then you subtract 25%. So half of 220 is 110, half of that is 55. You take 55 away from 220 and you get 165, right? And so what you could do here is you could just say, well, this is 60 times 100, this is 20 times 120, this is 20 times 165. I can figure out which one's the biggest there, and that's going to be enough. It doesn't change if like this goes from 60, 20, 20 to like 600, 200, 200, right? You just scale everything up by a factor of 10. Or if the values change here to like, 200, 240, 330, you just scaled everything up by a factor of 2. And because the scales are consistent across each package, it doesn't matter what the actual values are. So this one's going to be answer B. This one's tricky because like they only give you percent relationships. You don't need a dollar amount. You don't need a dollar amount. This is a C-trap problem, I believe. We'll pick answer B and move on. All right. Oh God, these two-part verbal questions always like make me a little nervous. Strategy games. Okay, board game X, traditional openings. I don't play enough board games, so okay. Strategic sequences of moves, right? That are most advantage against opponents who understand both traditional and non-traditional. Okay. Traditional openings are most advantage in one context. Cool. But and also against those who don't understand anything well, right? So if you're playing against someone who doesn't understand anything, keep it simple. Be traditional. Non-traditional openings are most advantage against opponents who only know the traditional one. So you're like, they're expecting you to do something traditional, and you throw like some like weird move at them, and they're like, what do we do? Aggressive open. Oh God, there's another one. Aggressive openings, whether traditional, generally favor a player who uses them against an opponent who's less experienced. All right, so be aggressive when your opponent's a beginner. It's like be mean to them. And then defensive openings tend to reduce an opponent's advantage when used by a player less experienced. So if you are the novice, if you are less experienced, you should be defensive. Don't be reckless. Okay. Aggressive traditional. An aggressive traditional would be most advantageous. Okay, so when are you aggressive? You are aggressive when you have more experience, right? And you're traditional against opponents who understand traditional and non-traditional, and also against those. You're traditional against people who like, well, let's see what the answers say. You and your opponents understand the same openings. Now I want aggressive to say like, I have more experience. Your opponent has more experience. No, that's the opposite. Your opponent, this one looks good. Your opponent understands both traditional and non-traditional. So that is when you want to be traditional. Okay? They're most advantage against an opponent who understands both traditional and non-traditional. Good. But you want to be aggressive when you have more experience. That one looks good. You want to be defensive non-traditional when your opponent has more experience, right? Defensive says here, reduce an opponent's advantage when used by a player with less experience. So if I have less experience, my opponent has more, I want to be defensive. And remember, non-traditional is when like your opponent only understands the boring stuff. Non-traditional openings are most advantageous against opponents who understand only the traditional openings. Understands only traditional opening. This is kind of like just find the text support. It's like a reading comp. I was going to say it's like critical reasoning ask, but it's really almost like reading comprehension here. Find the direct text support. Yeah. It does say most strongly suggests, which would be like kind of an inference problem. It does kind of seem like a specific detail problem to me a little bit here. All right, what do we have here? Okay, I got 6 questions left. All right, got to move here. 6 questions, 13 minutes. 8 items advertised on the internet, single page, sale. All right. Page placement, quadrant, mean time. How long do I look? Info click percentage. Who clicks the button? Sales rank. Makes sense to me. Okay. Which of the following can I know to be true? Which of the following can I? Info click percentage is directly proportional to mean I time. Directly proportional means there's like a linear relationship. So let's go to info click percentage and just rank those up. Directly proportional to I time. This triples, more than triples here. I time does not triple. That's a no. 2 items having the greatest sales. Let's go ahead and rank by sales. Were advertised in the upper part of the web page. So greatest sales, upper right, upper left. That seems correct. Mean I time was greatest. Sort by mean I time. For the item having the greatest info click percentage and least for the item having least info click percentage. All right, so mean I time was greatest. 6 point. Why didn't this sort right? Mean I time. Oh, it's sort of idiot alert. Sorted from least to greatest. 8.42. Highest info click percentage. 74 looks to be the highest. Yep, good. And then the lowest mean I time, least info click percentage, that one looks good too. I'm gonna click yes. 12 minutes, 5 questions. Let's go. Sheldon left his house at 8:30, drove to his friend's house, arriving later that morning at 11:30. So took 3 hours. We're gonna assume no time change. How many kilometers did he drive? So what I've been given here is I've been given a time is 3 hours. I've been asked about distance. And so like probably need rate, right? Probably need the rate. He stopped twice along the way. Very unhelpful. Goodbye, Andy. We're going to put the boo notice here again. His average speed while he was driving was 96 kilometers. Okay. Well, that's great. The 96 kilometers by 3 hours would be 96 times 3. That's like a certain amount, but it says like while he was driving, right? So that's, I don't know when he wasn't driving. Statement 1 says he stopped twice along the way. How long did he stop for? Did he stop for like 2 hours, a total of 2 hours and 59 minutes? If that's the case, he drove like not very far at all. If he stopped for like 1 minute twice, then he's spending most of the time on the drive going at this rate. This is not enough. This is answer E. We'll keep going. Next. Oh, when all the boxes in the warehouse, another DS problem. Arranged in stacks of 8, there were 4 boxes left over. All right, pause there. All the boxes arranged in stacks of 8. If there were no boxes left over, you'd have a multiple of 8 boxes. There are 4 left over, which means you have 4 more than a multiple of 8. 4 more than a multiple of 8 is a multiple of 4, but it's just not an extra special multiple of 4. There are more than 80, but fewer than 120. How many boxes were there? So I might just list all the multiples of 8 or 4 more than a multiple of 8 between 80 and 120. Shouldn't be too tough to do. 80 is a multiple of 8. I need 4 more than that, so 84 is the least value. And I'm just going to start adding another stack of 8 here. So add 8, add 8, add 8, add 8. So here are my options, right? This is what I'm choosing from. Which one is it? Statement 1, if all the boxes had been arranged in stacks of 9, there would be no boxes left over. So that implies the total number of boxes I have is a multiple of 9. Only 108 here is a multiple of 9, right? Like 108 is a multiple of 9. All of the rest of these differ by 8. So they're not gonna work. You can add up their digits, whatever you want. But the answer has to be A or D here. We're gonna give it a yay instead of a boo. And then statement 2, if all the boxes had been arranged in stacks of 12, this also implies that there's a multiple of 12 boxes, but the issue there is I could have 84 and I could have 108, right? multiples of 4, which all of these are, they overlap with multiples of 12 every multiple of 12. So 84 is a multiple of 12. The next one would be 96. It's not present. The next one would be 108. So statement 2 is not sufficient. Statement 1 is 108 boxes. Here we go. All right, 3 minutes. All right, 3 minutes of problem. Here we go. Got a graph problem. And I know I'm not going to get an extra MSR. This is great. Okay, so basically employee types by a different decade at a certain medical clinic. The total number of employees was exactly twice the number of employees in 1970. Cool. So like even though like this 50% is less than this 60.9%, because 2010 is twice the number of total employees, this value would actually be a larger pure value than this one. So things like that to keep in mind. Cool. The ratio of the number of physicians employed at the clinic in 1970 to 2010. All right, so where are the physicians? Oh, it's the blue ones we're looking at, is approximately what? So what I could do is I could just imagine that this, that this value is like there's 100 people there. And we'll just round because we are allowed to approximate. If there's 100 people here, this would be like 61 people. But then it says there's twice the number of employees in 2010, so there'd be 200 people here, and 50% of that would be 100. So I'm looking for something like 61 to 100. 61 to 100, well, they have tiny values. 61 to 100 is basically 60 to 100, which is 3 to 5. So I'm going to hope that that's the value. That looks good, 3 to 5. Yeah. They could make this a lot trickier, I think, if they had like a 6 to 5 option in here, right? But I think it's got to be 3 to 5. At least that's the way I'm proceeding here. This feels like I could be falling into a trap, right? It does say physicians, not physicians assist. I could definitely see myself screwing that up, but they didn't get me on that one. They might have gotten me somewhere else though. Number of employees, it's not like the number of nurses or something like that. It's the number of total employees. All right, I feel good. We're gonna move on. All right, 2-part, sorry, assistant professor. Why is it so detailed? Assistant professor. Does this problem matter if it's an associate professor? It does not. Oh, maybe because they're going to get tenured. Okay, makes sense. One of the requirements is a performance score of at least 4.0. Okay. Performance score is a weighted average of 3 components: one for research, teaching, service, which each research and teaching is 20%, services. Research and teaching is 40%, service is 20%. All right, components scored between 5.0 and 0. All right, what's the minimum score that the professor can receive for service and still get the 4.0? Okay, so what I want to do is, like, in order to figure out the minimum score possible here, I'm going to try to maximize everything else. So like, let's say they get a 5 in, so min for service and 4.0 overall. Okay, min for service, let's see. Well, if I suppose teaching is a 5, and then research is a 5, right? And I take 40% of each of these, that would be a 2 and a 2, right? I'm already at 4, right? So you can crush the teaching, crush the research, and just be the worst person worst person of all time at service, and you can still get a 4, right? It says at least 4, it doesn't say more than 4. So I think I'm good here. A 5 of teaching, a 5 of research means I could actually totally suck at service, and I can still do this. And then, and then what's the minimum research score? So the minimum research score, we do the same thing, min for research and 4.0 overall. Imagine the teaching is a 5. Imagine the service is a 5. Okay, 5 minutes left. Thank you very much. Go away. Imagine the service is a 5. So this is weighted 40%, right? Teaching is weighted 40%. That's worth 2. Service is rated at 10%, so that's worth, 20%, so that's worth 1. What is going on with my text box? That's worth 1. So far I've gotten to 3, and I need to get the 4 overall. So this would require, I need 1 point from research, right? I need at least 1 point from research. And remember, the 1 point would be set to equal 40% of the research score. And so 1 point is 40% of what? Right? 1 point is 2/5 of what? Well, multiply both sides by the reciprocal of 2/5, 5 halves, and you would get 5 halves is my research score, or 2.5. So I think the minimum research score I can get is 2.5. Again, like 40% of 2.5 would be 1. And that's still, I can still do it. Like if I really get only a 2.5 on research, I still think I can do it because I got 1 point from that. And then if I max out my teaching, that's worth 2 points in the weighting, right? 40% of 5 is 2. And then I can get 1 point for service. 20% of the max score of 5 is the last one I need. This one looks good. And last problem, 3.5 minutes. We've done this pretty well. The velocity of a model rocket is given by this. I remember this equation from physics. C is a constant. Cool. What's the velocity of the rocket 2 seconds after it was launched? All right, so it basically tells me t is going to be 2. Let me bring this back up. Right, it basically tells me t is going to be 2. So v is equal to here negative 32 times 2, which is negative 64. Okay, negative 64 plus c. Right. So if I want to figure out like what is v equal to, I could also figure out what is c equal to. Right? Does anything tell me what c is? Right, that would be great. Let me look at statement 2 first, right? I don't want to deal with this maximum height thing right now. A rocket's initial velocity was 48 feet per second. So initial velocity will be when time is 0. Okay, so when t is 0 here, v is 48. That means c has to be 48. That's the only way for that to work. And if c is 48, I could then solve this. So statement 2 looks pretty good to me. Let's go. All right. Take a look at statement 1 now. The rocket reaches its maximum height and begins descending 1.5 seconds after it was launched. Okay, this does remind me of physics class. This seems like a little tricky. Maximum height. Does it imply that I guess it implies that this rocket is is launched directly upwards and has no like horizontal velocity. It seems like a little unfair. But let's see here. Rocket reaches maximum height. I mean, I want to say that this is sufficient. I'm just trying to see if there's any tricks here. Okay. I guess what they're trying to imply here is maximum height is where the rocket pauses on the way up and comes on the way down. So it like stops momentarily at its maximum height. And if it stops, its velocity is 0, right? So basically when it says when time is 1.5, the velocity turns to 0. So what we could do in here is just write out, okay, 0 is equal to negative 32 times 1.5 plus c. Solve for this. This would give you, again, negative 48. So c would have to be positive 48. Basically, there's a specific value of c that solves this. So you can figure out what c is from statement 1. So that also seems to be sufficient for me. Statement 1 was sufficient. It just told you what c was, 48. And actually now going through statement 1, seeing that c is also 48 here, it does seem to be that they are implying that you do get like the rocket is launched straight up. I feel like they should have said that, but it was not, right? It should be like the vertical velocity. Feel good about that. So we would now have the ability to go back. I did not mark any questions for review. I definitely did on the real exam. I marked a couple questions. I went through a little bit faster and had time, but I marked through, I went through the questions there, and let's see what happens. Cool. On the actual exam, I took this like 3 weeks ago. I had enough time to revisit some data insights questions, and I definitely changed one from wrong to right in my review. I think today with the it was like kind of a challenge, just kind of talking a lot and explaining how I was going through some stuff. A little distracting, but actually kind of fun. I probably just like didn't have enough time to do that. But on the actual exam, I would have probably been marking some stuff as like things I might want to go back and double check. I clearly should have double checked something because I missed something here. But we will find out what it is. Does anyone know what I missed? Someone tell me what I missed. I'm sure someone out there caught it. Going a million miles an hour here. I actually have no idea which one it was. There were a couple times I thought like I might have gotten caught, like going too fast or not being super focused. But yeah, the quant and the verbal were pretty abysmal. That's because I just kind of clicked through them really quickly. I did like try the first quant problem the other day when we were doing the tech stuff, and I just wanted to see if how it would look on the stream. And then after that one, I think I clicked answer A for the rest of the problem. So hey, if you click answer A for everything, you're looking at 8th and 9th percentiles. All right, let's take a look. Anyone? Yes, physical whiteboard confirmation. I've erased everything. Does the proctor need to check? Can I go on my break now? All right, let's click next and go review this. I gotta go figure out where this stuff lives. It lives right here. How convenient. So I actually really like the score reports now. Pretty useful, right? I think they're an upgraded version from the kind of the classic version of the GMAT's enhanced score reports. I think they're better. They give you some cool insight. I love that they actually tell you how long you spend on each problem. So we could see the quant section here. I did the first one in a minute, and then this was basically a race of like, how quickly can I select answer A and hit the next button and the confirm button? And well, answer A is like never right, apparently. Um, don't take that as a fact. It was rarely right on this exam, I will tell you that. I wonder if the exam adapted to me as like, this person's only picking answer A. Let's not give them any questions where the answer is A. In the verbal, yeah, okay, 4 out of 23 questions was A. That's like within a normal distribution. Data insights, yeah, let's take a look. Bombed. It's one of the flight ones. Yeah, that flight one was kind of annoying. Um, Very curious to look at that one though. And then you can see, I do love this. I love like seeing how long we take on individual problems. I felt like I was maybe like a little behind at the beginning because I was talking a lot and I needed to pick things up a little bit, which is why you see probably like more ones down here. And then when I got to the end, I was like, oh, I actually do have a little bit of time to talk through this. Yeah, the content detail stuff is kind of cool here. This is when I took the actual exam. Again, like was it 3 or 4 weeks ago? I guess it's 4 weeks ago now. I I missed one problem on DI. It was like similarly placed, like right around here. But I got a 90 that time. So I must have missed maybe an easier problem this time. That would be my suspicion. So I got a 90 the first time I did the only time I've done the actual exam. When I took it last month, I got a 90 in DI, I got a 90 on quant, and I got an 86 on verbal. I missed the very first verbal. I took verbal first. I missed the very first question on the whole test. But then things apparently picked up from there. And I didn't even like review that one. There was another verbal question I changed from wrong to right. I didn't even review the first question. I didn't even think I missed it. Nope, I definitely missed it. I also saw the hardest quant problem I've ever seen, like in my entire life, on anything GMAT related. It was question 7 in the quant section, and I looked at it. I was like, I don't know how to do this right now. It's going to take me a while, and I had enough time to come back to it. I ended up spending 7 minutes on that question in the review. I ended up solving it correctly. But the only reason I knew how to do that problem is because there was a question in one of the official practice exams, like official practice exam 1, I think, that I saw that was also pretty devilish. And the learning takeaway I got from that is what I applied on that really tricky one. So it just goes to show you, your review can really, really benefit you. Like seeing common patterns and common structures, you can apply those on problems that are pretty difficult. Let's take a look at some of these. So, yeah, this one I think is kind of like a hidden weighted average problem. I mean, it initially looks really tricky because it's like there's 3 pieces to the weighting, but ends up not being, you don't need all 3 of them. The key inference here, I believe, was, do I have that whiteboard still? I mean, I kind of used the whiteboard at some times. We'll just see, where is it? It was this one, right? A quarter, 2/3, there's a missing 12th. So I know a 12th of the people like donate a lot of money. And so I'm trying to figure out, well, how much did those people donate on average, right? And the only thing I really know is like how much the middle group donates on average, right? Um, and so what statement one tells me is it tells me information, it tells me the average of the quarter plus 2/3, the people who donate the least or the middle amount. And so because I have like the relative size of those populations, and I have the larger kind of populations average and then the total average, I could figure out the smaller population, the people who donate the least. I could figure out what theirs is with a weighted average method. Yeah. But that doesn't tell me the people who donated more than 1,000. And then statement two, now I get like the average of the two top groups, okay, is 360. And so you could almost create like one of those seesaw teeter-totter systems and say, well, there's 8 times as many people, 8/12, who donate an average of 180 as there are people who donate a lot of money. And the average of kind of that entire 8/12 plus 1/12 is 360. What that tells me is 360 is 8 times closer to 180 than it is to whatever the actual amount is, right? Because these people, there's 8 times as many of these people, right? So their average amount counts 8 times as much. And so I had to figure out what's 18 times 180. I think it's 1440. Add that to this, and that would tell you actually that the average for these people is like $1,800. Um, don't need to actually do all of that, but the key is to see that that weighted average is enough here. Let's go to the next one. Yeah, hopefully this one was pretty clear, right? Looking at the totals, total volume of annual precipitation that returns is lowest where. So, you want to take this kind of, is this yellow? I'm colorblind, it's hard for me. Whatever this top bar is, that percentage times the amount and see which value is the least. You probably don't even need to bring out the calculator here. 65% of 7,000 is going to be less than 65% of 8,000 for sure. And then 65% of this like small number is going to be quite a bit less than even a smaller percentage of a much bigger number, right? And then, yeah, another weighted average problem. The first two questions are kind of weighted averaging here. Looking at Asia and Europe together, we're looking at runoff, so 35 and 45%. Those are the bounds. So it's somewhere between 35 and 45%, and it has to be closer to 45 and 35 because Asia has so much more total volume. I think there's only one answer, like between 40 and 45, 43%. Could use the calculator, don't need to. Cool. Hopefully this one was pretty self-explanatory. Sort by the first column. There were 7 people who made over 200,000, so not 6. There were actually there's no one who received a bonus of exactly 800 because the people who got the $800 bonus also received the $300 bonus. So those people each got $1,100, which is what the second option says here. Kind of want to get to the flights problem. Yeah, this is simple potential testing cases problem, right? We supposed like there was 1 letter on each day. We supposed there were 7 letters on each day. Both of those follow the rules of statement 1. Statement 1's not sufficient because like you could have 7 total letters or you could have 49 total letters, not sufficient. But statement 2, even if I tried to minimize how many letters Juana sent, right? The minimum would be for her to send letters in numbers of 1 through 7 on each of the 7 days, and 1 plus 2 plus 3 all the way to 7 adds up to 28. So that's got to be more. All right, here we go. All right, so we got this one. I actually want to look. Well, do we need to talk about this one? Implementation budget instead of $13 million. We did kind of like exhaustively go through these and like cross some things out. Yeah, the budget is $13 million. So there's only 3 lines that count: AD, AE, DE. Like they're the only ones that count right now. And then we have to decrease the minimum flight time. We calculated the flight time from A to D is 101 plus 78, which is 179. Did I write 179 or did I write 174? For some reason, I feel I wrote maybe 174 somewhere. I wrote it on my scrap paper over here, which you can't see, but that was a mistake. So if I said 174 at some point, that was definitely an error. It's 179, so I got to minimize that. Which ones do it? Does AE decrease that? AE 63 plus 57. Oh, that is 120. AE would take 90. What am I doing here? Am I even doing this right? Oh, because we're doing a CD. Yeah, we're adding CD. I'm just an idiot here. We add CD. Does that reduce? Does that reduce? I was right. CD is 174. Just please ignore the last 3 minutes of this video. Just go back, save, rewind, and go in a time machine. Skip the next 3 minutes of the video. 174. I'm trying to minimize that. Does line AD do it? No. Line AD 85 minutes. Yes, that did do it. If I add line, I see what we're doing. There's no wonder I missed the next problem. If line AD is 85 minutes, now I can get from now I can get from C to D in less time. I go 63 plus 85. God, didn't have any coffee today. Should have. I didn't want to be too jittery, but clearly you can see I'm still jittery. If I add line AD, which is 85 minutes, that does decrease the time from C to D. Yeah, 63 plus 85 is less than 96 plus 78. That's why we picked AD. That was it. Okay, look, enough of that. I've just embarrassed myself here. Okay, what the hell happened here? I thought we had this one. Which of the following proposed new flights would increase the total annual revenue by more than 10 million? Okay, so if I add BE, what did I do here? If I add BE, that is worth 18.8. You know what? I'm gonna bring the whiteboard here. I need to think through this. Pay no attention to this stuff on the screen. It has no value. All right, so I'm up 18.8 mil by putting in line BE. Okay, move down, please. I'm losing money though, because it says when I add a flight, I have to subtract 10% from the nodes that are related to it. Oh God, I missed this node. Dang, I forgot that line B has 3 things going into it. That was a huge oversight. Yeah, okay. So yeah, going too fast. That's what happens. I would lose 3.31 million here. Okay, so let's just write it like that. Minus 3.31 mil. I would lose 10% of this one. That's the key. I missed this one. 2.37, 2.73. That probably matters too. I'm going to lose 10% of this one, which is minus 1.81. Yeah, I can type. And I would lose 10% of this one, right? BE would connect to this terminus, which means it's losing 10% of this value, which is 1.76. And I think if I add all those up, like it's 1, 2, 3, 4, 5, 6, 7 just there. This might be the time for the calculator. But 7, that's an 8. That's already like if I'm like kind of thinking how the carrying would work. 3 plus 7 here is another one. 8 plus 7 here is like another one. Now I'm already at 9.5 million plus that I've lost. I go up by 18.8, but I lose 9.5. I haven't netted 10 million. So that would be a no. Dang, there it is. Ah, c'est la vie. On to the next one. This one I think was, yeah, should have a projected annual revenue of more than $20 million. So we can just go filter by that. Does AD do that? It does. Does BE do that? It does not. Does DE do that? It does. So far I know I can eliminate BE. And then, yes, we said it has to make travel possible between any 2 cities within 2 flights. And so DE did that, like it completed the Pentagon here, which means you can get from any one place to another in one pathway around the Pentagon, not even using a cutway through it. You can get from D to C, from D to B, to D to A, from D to E in 1 or 2 flights, which means you could do the same from any of the other ones because the Pentagon is symmetrical. And then line AD, if you do line AD, you're still in trouble connecting Duarc to Epster. Yeah, Duarc to Epster. I want to meet the person who names all the cities here. They always have like names of cities that are definitely not real, but like they could be. See if it's like it's an interesting skill that person has. Yeah, that one seems straightforward. Of course, I say that because I got it right. Question 6 was confusing. I think we talked about this one pretty well. What makes Bill A like higher priority than Bill B when it seems like they're on equal footing? Well, you weigh contentiousness more than uncertainty. That's what we had here. Yeah, so this is kind of the inflection point, which we said was really important here, right? The virtual meetings are more expensive. The face-to-face meetings are cheaper until you get to this inflection point, which happens at 14 meetings, when the total cost of the face-to-face meetings would equal the total cost of the virtual meetings. And the total cost of the virtual meetings are just the initial costs, right? The initial one-time costs necessary to set up online meeting capabilities. And once that's established, negligible additional cost. So set up the online meetings, 55,000 bucks. That is still the cost once you've held 14 meetings. 10. Yeah. Oh, I see some questions coming into chat. Pooja said, is the OG book 2023-24 sufficient for data insights? That's a good question. I think it's good to start. What is sufficient and what is not sufficient? That is itself a data sufficiency problem. It kind of depends on your goals. Like I think the official guide is, if you're able to extract enough value from the problems that are there, generally that is sufficient. It's enough. If you feel as though, you've run through that book and you need more problems, I just need more problems to practice. You can go get the kind of like the supplement book, right? The official guide review book for just data insights, like that would provide more problems. If it's data sufficiency in particular you need help with, there tend to be more data sufficiency resources or resources that have data sufficiency in them than there are for the tables, graphs, multi-source reasonings, and two parts. Just because data sufficiency has been tested for longer and on sections that count towards your score. So you could get like old GMAT books that test on data sufficiency. I will say though that data sufficiency, like the flavor of it feels different. There's less pure math, there's less number properties, there's less algebraic manipulation. There's more like, real life situations. And so, obviously there's no geometry either. So you need to kind of filter by which problems are appropriate in those old resources. And then, there are other resources out there you could get, like there is some overlap between, the GMAT focus material and like the executive assessment material. But, the executive assessment has been testing tables, graphs, multi-source reasoning, and two parts for like a long time. And so it might be that some of those resources could help additionally. So in general, what I would say is the official guide, I think, does enough, right? It kind of depends on where you're starting and what your goal is. The official guide generally does enough, but there are some other ways to supplement. Yeah, it depends on how well you use the resources too. This one we set up, right? 18 possible pairs. We kind of set up what was possible here. I think I did. Yeah, here it is. Basically, possible pairs of side dishes means you make a selection from the list A. How many options are there here? Times how many options are there in list B, right? And that product needs to be 18, right? So you can list out the factors of 18 that like are grouped in that way. And then it tells you there are fewer in A than B. So the numbers over here, their factor buddies, their pairs are greater. So these are your three options. So which option is it, right? Is it the top one with 18 in B? Is it the middle one with 9 in B? Is it the last one with 6 in B? Total of 9 side dishes on the list. That's this one. So there has to be 3 and 6, 6 and B. There are 3 side dishes in A. Got to be 6. This one does seem like, it seems relatively easy, like comparatively. And one thing I've kind of noticed is like, even if you're doing really well on a section, it seems more like this on the focus than it did on the previous version of the GMAT. But like, the adaptivity does not nearly seem as linear as it was on the previous version of the exam. And that's, they say that's part of the new algorithm with its like honeycomb pattern and stuff like that. But I was surprised on my actual exam when I was doing apparently pretty well on the sections that like in the middle of the sections, even sometimes towards the end of the sections, there would be problems that would seem to me relatively easy, just as this one seems, I don't know, relatively easy, despite the fact that I'd only missed one problem by the time we got here. I'll never forget that flight problem. Maybe there's like a little bit of inferencing to do here about 18 possible pairs and like what does that imply? So there is some inference making I'm doing. It is kind of wordy. You could get lost here. It might seem that like, statement 2 is like obviously sufficient, right? It's 3 times 6, so and then statement 1, you might be like, well, it could be 6 and 3 and or 3 and 6, and you forget this last little fact here. So I could see a lot of people picking B here. I could see a lot like the C trap is pretty clear, right? Like there's a total of 9 on the 2 lists and 3 on A. That tells you 6 are on B, right? So like that's a C trap. This one does seem, relatively easy for, kind of the success we were having through that. Yeah, this one we went through, and I went through it by just like plugging in numbers, realizing that like, Ramona's older than Charlie, and I could definitely like I could definitely agree if someone said, I did not catch what he was saying. He was talking so quickly through this because I had a feeling as I was going, it was going to be like the last one. So I was trying to blur through the rest of these. But essentially, what I was doing is, supposing Ramona's age was one of these. All right, we'll pick an answer that's not true. Suppose Ramona's age was 20. If that were the case, what would have to be true? Well, what would have to be true is that in 4 years, she would be 24. Okay, what's the next difference that you could make? Well, if she were 24 in 4 years, it says she would be twice Charlie's age then. So if she were 24 in 4 years, Charlie would be 12 in 4 years. So if in 4 years, Charlie is 12, you would be 8 now, right? And so 20 doesn't go with 8. And so like you could set up the algebra here. We'll just go ahead and do that for, just to be thorough. But what I'm saying here is like Ramona plus 4, right, is equal to 2 times Charlie plus 4. Whoops, Charlie plus 4, right? And so you could like simplify that. Okay, R plus 4 is equal to, 2C plus 8. And then you could say, well, R then has to be 2C plus only 4, right? And you could go through and like, I think this would be a great move as well. Like I'm not criticizing if you did this. This honestly, I don't know. It's hard to tell what I would have actually done on the test versus what I would have done to kind of talk out loud. I think it's 50-50. I might have plugged in. I might have done this. And you could now just plug in values for C, right? Like if we'll move this over here. If C is 2, then R would have to be 8. Doesn't exist. If C is 12, R would have to be 28. Boom. That's way faster. You could try that too. Yeah. Don't really have a preference. I think both ways are totally cool here. Question 12. All right, we did this one with the foods, right? One of these doesn't include a process or ingredient that all the others do. And really, I just kind of like looked at the answers. I just looked at the second blank here, and luckily, adding condiments was the first thing, and adding condiments is involved in 3 of the foods, right? So again, kind of this idea that looking at the answer choices in data insights is really valuable, right? We're plugging in. I just plugged in on the previous problem with Ramona and Charlie. A lot of these techniques that we advocate for on the quant side of the exam, you can use on data insights, right? Like look at the answers, estimate. Like again, like none of this is a math test, right? It's a logic test, and if you are not using your resources, including your answer choices, to help out with what's logically possible and impossible, you're probably leaving points on the table. You're probably leaving time on the table as well, or like taking time off the table. You're wasting time. Yeah, had the whiteboard up for this one, kind of tested some cases. I think this one's a potential trap for people thinking you need like a number, and you don't need a number, right? It's just like which one would generate the greatest monthly revenue, and so you can kind of compare percentage-wise, right? Which ones are greater. You don't need specific values. You need these kind of like proportional values to one another, and that's why statement 2 ends up being sufficient. It kind of compares TV only to internet with a percentage greater, right? 20% more here than here. And remember, like we already have information about combo, how it relates to internet and TV, right? So now now with statement 2, you have information about everything, and you know kind of the breakdown of the population that chooses these 3 options, right? That 20% and 20% is a really key inference. It's not explicitly told to you, but we're going to want to figure it out. Statement 1 tells you a price for internet only. We went on the video earlier, we went through and like proved that by saying, well, if it's $25 for internet and $1 for TV, like internet is the biggest revenue generator. But when I test cases, I like to test like wildly different cases, because the goal of testing cases is to try to show that a statement is not sufficient. It show that it doesn't, like it allows too much wiggle room. I want to see like how much wiggle room is allowable in statement 1. And I said the other case I could test if the TV subscription costs like a ridiculous amount of money, like $1 billion per person. Now that's how the cable company is making its money, right? So statement one's not enough. And then we kind of tested the cases here to prove why statement two was enough. We said it doesn't actually matter how many people or how much money they cost because they scale up proportionally. And if the parts of a product, right, 60 people times 100, 20 people times 120, if those individual pieces of the product scale up proportionally, then so does the end result. So what was greater in one case would be the greatest in the other cases. 13, 14. All right, yeah, we don't know. I don't know if I need to go through this one again so much, but basically what I would say here is this one is sounds like a reading comprehension passage to me. Where's the text support? So where's the support for aggressive traditional? Aggressive is here, right? Favor the player less experienced, and then traditional, advantageous against opponents who, understand traditional and non-traditional, and that's what this third option says, right? Talks about the experience in the right way, talks about traditional and non-traditional, and same thing for defensive and non-traditional. You're defensive when your opponent has more experience. You're non-traditional. You're getting like a little wild out there. You're being unpredictable when your opponent only knows the predictable stuff. But yeah, find that support in the text, right? Yeah, I remember going through this one pretty quickly because I was a little worried I wasn't going to finish the section, and that would have been truly embarrassing. Yeah, what can be inferred based on this, right? So we have 8 different types of advertisements. Where are they placed on the page? How long? Or I guess there's eye tracking software. It's like the GMAT Online. They track your eye movement. Where are you looking? How long? What percentage of people make a click? And then what percent? Like what's the rank in sales? They don't actually talk about sales rank in the questions, but they could have. Info click directly proportional to mean eye time. We just sorted and said like, hey, is there a direct linear relationship? All I had to do was look at like the first two here, right? If info click is directly proportional to mean eye time, when this triples or actually more than triples, this should triple or more than triple, and it does not. So that's a clear no. Look at this one over here. 5 to 74%. That goes up by a factor of 15. That would imply that this person is looking at the ad for like a minute and 40 seconds. That's ridiculous. 2 items having the greatest sales were advertised in the upper part. Oh, we did talk about sales. I am a liar. I'm a huge liar face. We sort by sales 1 and 2, and they are both in the upper. That one seems pretty clear. And then mean eye time was greatest for, go ahead, do that. Mean eye time was greatest for the thing that had the highest info click percentage, that checks, and least for the one that has the least info click percentage, that checks as well. This one seems relatively straightforward. Again, like this table seemed easier than some of the other tables, like the bonus question. The bonus question, which happened, I don't know, in the first, I think that was like the 3rd or 4th question. This seems much harder than this one. So again, like it's interesting that every now and then they throw some questions, at least to me, that appear easier. And again, we'd only missed one problem at this point. So like, what's going on there? Part of me suspects like they're trying to see if people spend too much time on the earlier part of the section and like haven't given themselves enough time to answer questions at the end that might be easier. So like you get potentially punished even more for that. Hard to know. I'm just speculating here. But what I have noticed is the difficulty does not seem linear. Like on the old score reports, you could see like by quarter and section, like how hard was the average problem in that quarter of the section? How hard was the average problem that you got right? How hard was the average problem that you missed? And you generally see something that like would trend up if you were getting everything right, or trend down if you're getting things incorrect, or it made sense. And here, like I'm not sure it is as clean, like this one. It also could be that the question bank's not deep enough, right? These are the free exams, so they might not throw in like as many problems as possible. So they may have just like run out of questions at a certain difficulty. Again, hard to know. This one seems a little, I don't know, this one seems a little tricky. The last one with the projectile seemed like kind of like a weird problem. But the stopping twice along the way, right? Remember, statements are always true. Take that as a fact. I have no idea how long he stopped, which also implies like I have no idea how long he was driving, right? Of the 3 hours, like was it 90 minutes of driving, 90 minutes of stoppage? Ooh, you have no idea. So if you don't know how long he was driving for the 3 hours, you don't know, even though you know the rate, you don't know the time to multiply the rate by. It appears to be 3 hours, but you don't know what the actual driving time was. Oh, yeah, talked about this with the multiples of 8 plus 4. Yeah, I like these problems. So like this is, I guess this is kind of a number property question, but it's done in a word problem, right? It's not like pure math. It's not saying like, if n is equal to 8x plus 4, where x is an integer, and n is greater than 80 but less than 120, what's the value then, right? Like that's the equivalent problem here. But this seems more accessible, right? Because it's about physical things that you could see and imagine them stacking, right? But it's essentially the same as like a divisibility remainder problem. But they just present it to you in more real world terms. I don't know. I should take a look. Was question 17 a real math, a pure math, or a non-math problem? I guess they would call this math related on DI. On the quant section, they say pure math or not pure math. But we kind of listed out examples for like, what are the possible number of boxes there could be such that it follows this rule? I need numbers between 80 and 120. And I need things that could be stacked in groups of 8 with 4 left over, which means a multiple of 8 plus 4. So I went and found the multiple of 8 closest to 80, which happens to be 80, and I added 4. And then we just keep adding stacks of 8 until we get to the upper limit. So it's one of these. Which one is it? So I have 5 cases in general, like on a data sufficiency problem. If they basically present a very limited number of options, right? I did this for the list A sides, list B sides, like 1 and 18, 2 and 9, 3 and 6. I just want to list those out. I want to see the universe of possibilities here because it's pretty finite. And then once I have that, I'll use the statements to kind of filter the possibilities. So if all the boxes arranged in stacks of 9, no left over, multiple of 9, 108 is the only multiple of 9, sufficient. Yay. Statement 2, stacks of 12, no boxes left over. So I also have a multiple of 12, but actually there are a pair of multiples of 12. 84 is 12 times 7. There'd be 7 stacks of 12. And 108 would be 9 stacks of 12. So close, but no cigar, not sufficient. Answer A. 18. We spent some time on this one. This one really felt like it was going to trick me, just because maybe I was moving too quickly. But again, I don't know. As long as we know which kind of bar we're looking at, right? The question's about physicians, not about physician's assistants. And it says the total number of employees in 2010 is double this. I could just smart number this, right? Again, a quantitative technique we could do. I could just say, what if there were 100 employees here and 200 here? What would that mean for like what these blue bars represent? 60 to 61 physicians, 100 physicians here, 60 to 100 is about 3 to 5, does say approximately. So I was looking for something too fine. I was looking for 61 to 100, but I saw the very tiny numbers and I was like, oh, yeah, okay, tiny numbers, think of a clear ratio. That's 60% or 3/5. That one, again, that one seemed like it could have been harder than it was, but it was not. This one I do think was kind of tough. Another kind of weighted average problem here, although I don't generally like thinking of the weighted average method when I'm dealing with 3 pieces. I don't want to deal with that seesaw then. I think it's a little unwieldy with 3 things. You can do it. It's just kind of annoying. So I think the key for this one is in general, and this will happen on the quant section, but when you need to minimize something that's part of a whole, okay, and like the service score in this case is part of the whole. If I'm going to minimize this and still like reach a certain threshold, what I need is for the other pieces to carry the weight of the very poor service score. So I want to, in order to minimize this, I need to maximize the other things, right? And so that was the move here. How do I find the minimum service score and still reach a total of 4.0? Well, I'm going to max out these, right? If teaching's a 5 and worth 40%, this contributes 2 full points to the overall score. If research is a 5 and it's also worth 40%, it contributes another 2 to the overall score. That's 4. I'm already done. As long as I don't get a negative score on service, I'll be okay. And then same process for research, right? Just remember that service is rated at 20%. And so a 5 in service only counts as 1. You need 1 more point for research. So yeah, even if you get a 2, if you get a 2 on research, 40% of that is only like 0.8, that's not going to get you to a 4 overall. That'll get you to a 3.8. So you need the highest score there. Yeah. And we got one more. Una más. One more. Yes, the rocket question. Yeah, this one is kind of strange because I feel as though, I've launched a model rocket before, and let me tell you, it does not land exactly in the same place you launched it. There is some trajectory in the other dimensions, but I guess they are hoping you don't think about that here. So what we did on this one was we kind of said, in order to figure out the velocity, I would need, after 2 seconds, I have an input for t. I would also need to figure out what c is, right? So if I can figure out what c is, I can figure out the velocity. We did statement 2 first. Initial velocity implies time is 0, right? We plug that in. If t is 0, then this becomes a 0. So if the velocity is 48, then c must be 48 at that point. And if c is a specific number, you know v. Statement 2 is sufficient. We looked at statement 1. The maximum height bit implies like it stops and starts falling. It's on the way up, right? So like you give it an initial velocity and it starts slowing down, right? That's gravity doing its work. Slowing down, and eventually it reaches its apex, its pinnacle, stops for just a second, actually less than a second, instantaneously, and then it falls. And so after 1.5 seconds, it stopped. Its velocity is 0. You input that, you can figure out when 1.5 is t, velocity is 0, you can figure out c. And again, if you can figure out c, you can figure out v after 2 seconds. And that is the gist of it. That is, no, I feel like I just went through all the questions again the same way I did it the first time. But yeah, that's what I got. Let's go back to the score report. Let's check in on the comments. There are some questions. Cool. So a couple more questions about the Focus Edition. Yes, it is. It's supposed to be. It's adaptive in a different way than the previous version of the GMAT, but it's not adaptive in the way that the GRE is, which is it's like they adapt section by section. This is not section adaptive. So when I took when I took the quant section first on this exam, I didn't really take it. I guessed A on everything. How you do on the quant section is not supposed to dictate how the next section begins, right? It's like clean slate. You finish the quant section, you could get everything wrong on the quant section, and then on verbal they're like they don't even remember what you got on the quant section, so they're not going to start you with really easy verbal questions if you do poorly on the quant section, and they're not going to start you with really hard questions on the verbal section if you kind of absolutely crush the quant section. It doesn't work like that. It works like that on the executive assessment. You have to take the integrated reasoning section first there, and then how you do on integrated reasoning dictates where you start on both of your next sections, right? Dictates where you start on verbal. It also dictates where you start on quant. But they have not said the GMAT Focus does that. And then another question is, yeah, right now I'm preparing for the Focus Edition. I have a certain score target. And I'm targeting a 700 plus score. Okay, so something to know here. One sec, I'm going to pull this up. I'm going to try. GMAT Focus. Can I find it? Cool. Let me share a different window here. Something to know here is, one second. I will be presenting something new in one moment. Sorry, I am not the most tech savvy person. I want score concordance tables. Let's share this. One second. So something to notice here is like the score scale on the GMAT Focus, right? They all end in 5s to allow schools to distinguish between the older version of the GMAT and then the current version, the GMAT Focus. But what you'll see is like a 705 is not like between a 700 and a 710. Like no, a 705 is actually like a very, very strong score. Like a 700 would have been a strong score on the old version of the GMAT. A 705 is like a very elite score. basically they've created this table that shows how scores on the older exam are supposed to relate to scores on the current exam and vice versa. What you see is a 705 is like, that's like a 750 on the old exam. So when I hear students who, understandably are looking at programs and they're seeing these scores, they're like, oh, the school that I want to go to has a median score of like 710, 720, right? Or their average is like 721, right? Things like that. And so then they say, I need at least a 720 or 725 on the GMAT Focus. Like a 725 on the GMAT Focus is not the same as a 720 on the old exam, right? So take a look at one of these concordance tables. I just Googled like concordance, like GMAT Focus concordance table, and I found this link pretty early on. And this is released by GMAT. It's a little dated. I think they have an updated one. They might have an updated one, but it's mostly the same here. And you can say, well, if I'm targeting a 700 plus score on the old exam, right, that's like a 655 on the GMAT Focus. So maybe you're not as far away as you think you are. Question came in about section order. What should your section order be? That's a preference. I think it kind of depends on your strengths and weaknesses. I will tell you what I did is I took the verbal section first. Verbal has never been my strength of these sections. Verbal is more exhausting for me because of the process of eliminating wrong answers rather than just like nailing the right answer all the time, which I feel as though I'm better equipped to do on the quant and DI sections. So verbal is more exhausting. I need to be at the top of my mental powers for that section or else I'll suffer. So I will do verbal first to prioritize that section. And then I took the quant section second. I did not take a break between verbal and quant. I took the quant section second because quant has always been like my strongest area. And so I feel as though I can, I don't know, I don't want to say like it's not easy, but it's not as intense for me. And so I usually finish a little early there. I can take a little bit more time to review and it doesn't feel like as much pressure. And then I took my break and then I did DI. What Manhattan Prep kind of recommends is, if you're worried about the quantitative like areas on the exam, to at least separate the quant and DI section by putting verbal in between them in some way, or by putting the break in between them. And so that might be something to think about. If you feel really good about quant and are worried about verbal, and verbal is really taxing for you, maybe you separate verbal and DI in that same way. And I did both, right? I put verbal and quant, and then I put my break. And then DI kind of just chilling on an island down below there. Yeah, that's it. Cool. Yeah, we can stop sharing this. No one needs to see this, but it's a good resource if you want it. It's out there, publicly available. So go check it out. Yeah, any other questions out there? This was kind of fun. I don't know. Hopefully it wasn't the worst time for you. I want to thank GMAT Club for having me on here. Always a good time to get involved with GMAT Club. Thanks for watching. If you're watching live, if you participated in this section with me, very cool. Hope you had a good time and learned some things. If you're watching online, yeah, I hope the experience was also valuable for you. Yeah, I remember we're going to have another one of these. One of my colleagues, I believe Ryan Jacobs, is going to come and do one of these in a couple of weeks, although I've heard he might do a different section other than DI, so stay tuned for that. Watch out for those like GMAT Club announcements on when those events are going to happen. Yeah, and yeah, the recording should be available. Usually they put these recordings out pretty quickly after it happens. So yeah, the turnaround on this is pretty great. So you just check out the GMAT Club YouTube channel and should show up. I don't know if I'm going to watch it. I don't like hearing my voice back on the recordings, but maybe I will. Very cool. Yeah, so same link. Very cool. Well, again, I'm Jeff here with Manhattan Prep. Been a lot of fun. If you are studying for the GMAT Focus, really good luck. If you're taking your exam soon, go kick its butt. If you have any questions, feel free to, look us up, drop in on one of our free events, and maybe we'll see you out there. Thanks, everyone. Had a good time.